So up until now, the only thing you've really done is have enemies patrol back and forth in your platformer game. Today we're going to adjust all that. That way it's ready for your Capstone project. So let's get started. What we're going to end up doing is we're going to use a technique called dual line of sight. So when the enemy loses visual contact with the player because of a wall or something, it doesn't give up. Instead, it just projects a ring of visible virtual tiles or nodes around the player's last known location. It then is going to ask two questions. First, can the node see the player? And second, can I see the player? If the answer is both yes, the enemy knows the node is a safe corner it can walk to. It picks up the closest valid node, creating a perfect unobstructed path around the obstacle. Alright, so first thing you want is an enemy AI script. So let's create that. Enemy AI. We'll say movement is what we'll call it. Enemy AI movement. Now, inside of this, once it compiles, we're going to drop it on our enemy and open it up. Alright, now that it's open, we're going to add in some variables here. So let me get these for you. So instead of relying on the physical issues to slide our enemies around walls, we're going to calculate the path geometrically before the enemy takes its first step. We're adding a tracking radius and a node count, and then so that when the enemy loses sight of the player, it's going to use these to project a ring of invisible nodes around the player's last known location to try to find a safe path around the corner or obstacle that is blocking it. In order for this to work, though, we're going to need to get the enemy's rigid body 2D component. So we'll put that in the start menu. In our update function, the logic is going to be incredibly simple. We're going to ask one question: can I see the player? If the answer is yes, then we set our waypoint directly to the player's coordinates. If a wall is blocking our view, then we drop in a custom method that we're going to define called find corner waypoint to figure out how to avoid these obstacles. To do that, we're going to create two functions. One is going to be called has line of sight, which just uses a simple physics 2D line cast to check if the wall is between 2 points. Then we're going to create one called find corner waypoint. The way this works is we use a basic sine and cosine to generate coordinates for 8 nodes in a circle around the player. We're then going to test each node with our line cast. The rule here is dual line of sight. So if a node can see the player and the enemy can see the same node, we know it's a valid corner, and then the enemy finds the closest, we find the closest one to the enemy and set that as our new waypoint. Finally, we're going to add a fixed update, and what that's going to end up doing is applying this to the physics engine. Because our calculated waypoint is just a coordinate floating into space, we completely avoid any sort of jittering or wall snagging of physical collision checks. If we have a waypoint, we calculate the direction to it and apply it directly to our linear velocity. If we don't have a waypoint, meaning the player is completely hidden, we set our velocity to 0 and it stops it. So let's go ahead and save this code and then we'll test it out. Alright, so if we click on our enemy script, we're going to need to do a couple things. We need to put the player inside of the player target section. This obstacle layer, we need to add something to it. So we're going to come up here to the right to layers. We're going to add a layer. We're just gonna name it obstacle. You can just use layer 3 for it, and then we're gonna tag these wall groups as this wall group here as obstacle. Say yes, change the children, and then under enemy, obstacle layer is gonna be obstacle. Now let's hit play and see what happens. Alright, so you see the enemy's not moving right now, but now it's moving towards the player because it's casting those out, and once the player's hidden, it stops moving again. And then when we go back to where we can view again, the enemy starts its chase again. And so that's just a really basic, simple AI movement. And so there you go. I'll see you in the next class.